Yes, Hot Chip there from the album Why Make Sense. That was Dark Night. However, it's 6:45, which means it's bright morning, and you are listening to Breakfast on 2SER 107.3. Now, the recent Italian earthquake, which was quite horrific, over 240 people killed or injured, it's caused a bit of speculation that Earth has more earthquakes yet to come. And of course, countries that are situated on fault lines are on high alert. Those include Japan, Chile, Mexico, and even our close neighbour, New Zealand. Some people are even suggesting that big magnitude earthquakes are well overdue. Now, we only have to go back until 2011 to get an idea of just how devastating earthquakes can be when we look at Japan and the tsunami. So, the issue is that apparently earthquakes are remarkably difficult to predict in terms of scale or where it will hit. Now, joining me on the line from the UTS Geotechnical and Earthquake Engineering Division is Dr. Behzad Fatahi. Dr. Behzad, good morning.
Good morning to you and your listeners.
Yes, thank you very much. Now, look, my understanding of earthquakes is all very facile. I have a very limited understanding of what causes them, other than knowing it's tectonic plates kind of moving together. Can you give us a better idea of what's happening with an earthquake?
Yes, earthquakes basically happen when the fault lines, they rupture. So these fault lines, it might be in the middle of the tectonic plates, or it might be on the border of tectonic plates. If I just give you some idea how many tectonic plates we have on the planet Earth, we have got around 7 major tectonic plates. You may have heard of them, such as Eurasian, Australian plate, Pacific plate, and so on. Mm-hmm. We have got on top of that, we have got around 8 other minor plates, and we have got so many others that measure more than 10 or 20 microplates. So basically, planet Earth looks like a fractured eggshell that you can imagine how many plates it may have, and they are just moving over time. So sometimes these plates, when scientists, they monitor them, they see that these plates, they do not move in the rate that they used to move. So then that raises an alarm that basically we have to go and monitor them further. And then by monitoring them further, you will understand that apparently there has been a significant friction in a part of the fault that causing the fault to absorb more energy over time, because one side of the plate starts to move, however the other side, because of that large friction, can't move, so it starts to absorb energy. Then that fault is known to be said that is locked fault. So then basically you will wait till that lock breaks, and that's the time that it will release the energy. And basically all these many fault lines that I mentioned around the world, basically there is a very high chance in so many of them that they have been locked and they haven't released the energy for some time. And basically we are waiting for those energy to be released. And that might be, to be honest, today, tomorrow, or it might be in 50 years, 10 years time. So it depends on what would be the strength of that lock at that particular time. That makes it quite difficult for us to predict.
That sort of lack of prediction must make it extraordinarily difficult for countries living on those fault lines to be prepared.
Absolutely. However, don't forget, still engineers, civil, structural, geotechnical engineers, they design the structures and they stand the large earthquake very well. So the matter is that you have to design first those structures to the very good standard, really. And one of, just for your knowledge again and listeners, that's good to know that engineers, when they design the structures, they say, let's say, if a very regular structure, let's say every 50 to 75 years return period, if it comes, nothing should happen to the structure. If earthquake, let's say with a return period of 500 years, it attacks the structure. So if, let's say, the design life of a structure is around 50 years, we design it to stand there with a very minor cracks. Even we design the structures for a return period of 2,500 years to ensure that they stand there. However, people can just get out, and after that you may need to demolish the demolish the building. So we try our best, basically, even to consider for such a very high return period. So, but all those buildings that you see recently that they may collapse doesn't necessarily follow the standards. So that's the problem we have.
And Dr. Fatahi, just quickly, we saw, of course, with the Newcastle earthquake many, many years ago that Australia is on a fault line. How at risk are we, do we know?
The risk in Australia, obviously there is a risk. Australia is, the country of Australia is sitting inside the Australian plate, which is relatively in the middle, and we are not suffering much from the fault lines right on the border of the tectonic plates. However, there are a lot of intra tectonic plate faults that they are widespread in Australia, but mainly they are in central Australia toward Western Australia, southern part of Australia, Victoria and Tasmania, and of course if you go a bit offshore toward New Zealand. And of course you have heard of, I guess, these earthquakes recently also happened in Australia with a magnitude of 5.8, or what happened in New Zealand, 5.6, that killed even 13 people directly and indirectly. But the chance of very large earthquake in a magnitude of 9 or 8 or those things is very, very small in Australia, and we do not, technically we do not consider them. But of course, large earthquake over 6.5 maximum, I have seen that seismologists basically they try to report in Australia is around 7. But remember that these faults, you may talk about the magnitude, but remember these faults, if the length of the fault is not very large, it's not going to release a lot of energy. However, we believe that large earthquakes, relatively large earthquakes, can happen in Australia, but not in the magnitude of those very large earthquakes in the order of 8, 9 that you may have seen that they killed thousands of people.
All right, Dr. Fatahi, thank you very much for that, and we appreciate you talking to breakfast this morning.
No problem, my pleasure.
Dr. Behzad Fatahi, he's a senior lecturer with UTS, talking about geotechnical and earthquake engineering.